We know from published studies that quadrupolar magnets can block nerve cells from firing. The mechanism for this is thought to be by changing the cell membrane's permeability to sodium and calcium ions. A nerve cell fires with what's called an action potential. Action potentials propagate through a depolarizing process, whereby the voltage of the cell flips from negative to positive. This sudden change in the voltage of the cell is caused by electrical currents. These currents are made up of moving charged particles, which are mostly the flow of sodium, potassium and calcium ions through channels embedded within the cell membrane. The resting membrane potential of a healthy nerve cell sits at around minus 70 millivolts. This is maintained by the sodium-potassium pump and leak channels, which allow potassium to flow out of the cell, following its electrochemical gradient. An action potential fires when the voltage reaches minus 55 millivolts. It's an all or nothing step. If the voltage doesn't reach minus 55 millivolts, then the nerve does not fire. The cell voltage inches closer and closer to the minus 55 millivolt threshold with each stimulus. External stimulus, such as temperature, pressure, or chemical, causes graded potentials which can summate, moving closer to threshold. Once this threshold is reached, the action potential propagates along the nerve fibre through the central nervous system, and so, for example, a cut or touching something hot can be perceived as pain. With chronic pain, nerve cells often become sensitized. Part of the sensitization process is the cells become leaky to sodium ions, which raises the resting membrane potential of the cell. So instead of the cell requiring a stimulus that produces a 15 millivolt change in voltage, it might only require a 5 millivolt change. So an ordinarily innocuous input that would typically cause no discomfort suddenly is perceived as pain. By applying the magnetic field gradient that's produced by the quadrupolar magnet, it is blocking the pathways in which sodium is entering the cell. This brings the resting membrane potential back down to a normal functioning state and means that a normal stimulus is now required to perceive pain. Just like context-dependent drugs, Q-magnets appear to work in a similar way in that they only affect pathological pain transmission and not normal pain transmission, and without the side effects.